Welcome back to the deep dive. Today, we're jumping into something really interesting from Inception Labs. It's called Mercury.
Yeah, it's been making some waves. Definitely caught my eye.
It really seems to be pushing the boundaries for large language models, especially when it comes to speed.
Hmm.
We live in this world just flooded with AI promises, right? But usually getting things fast means sacrificing quality, especially with these big, complex models.
That's the classic trade-off, yeah.
But what if you didn't have to choose? That's what Mercury claims to offer. So today we want to unpack how these ultra-fast language models work. They use this thing called a diffusion approach.
Right, which is pretty different.
Exactly. We'll look at why it's potentially such a game changer, particularly for coding, and what these impressive performance numbers actually mean for you.
Sounds good. Let's get into it.
Okay, so at its core, Mercury. It's pitched as a new generation of commercial-scale LLMs. And the big shift is how they generate text, or code in this case.
Yeah, they ditched the standard, token-by-token method. That's where models usually predict the next word, then the next one after another.
Sequentially.
Sequentially, exactly. Mercury uses diffusion.
Okay, diffusion. How does that work? Is it like image generation diffusion models?
It's a similar principle, actually. Instead of building word by word, think of it more like starting with a kind of random noisy output, like a blurry idea.
Okay.
And then the model refines that entire output in parallel, all at once, step by step, until it becomes a clear, intended text or code.
So not one word at a time, but refining the whole thing together.
Exactly. And that parallel processing is why it's so fast. It just utilizes modern GPUs much, much more effectively than the sequential autoregressive models.
Gotcha. So more efficient computation. Now, they launched MercuryCoder first, right? Focused specifically on programming.
Yes, and that makes perfect sense. Speed is just critical in coding tools. Think about code auto-completion, or these new AI coding agents.
Yeah, latency there is a killer. If you're waiting for suggestions, it just breaks your flow completely.
Totally. High latency makes those tools almost unusable, or at least very frustrating. We've seen developers get really annoyed by slow autocomplete. Mercury aims to fix that.
So what are the numbers? I heard they were pretty wild.
They are. Artificial analysis did independent evaluations. Mercury Coder Mini, the smaller one, hits 1,109 tokens per second on an H100 GPU.
Wow, okay. 1,100 tokens a second. How does that compare?
It's massive. They're saying it outperforms other speed-optimized models by up to 10 times on average. 10 times?
That's hard to even picture. Generating whole code blocks almost instantly.
Pretty much. And the slightly larger one, Mercury Coder Small, still gets 737 tokens per second. And the quality is comparable to other top models.
Okay, so crazy fast.
Mm-hmm.
But is it just fast in benchmarks, or does it hold up in, like, real-world use?
Well, that's the other interesting part. On Copilot Arena, which is where real developers rate models, Mercury Coder Mini is ranked second for quality.
Second overall on quality, while being the fastest.
Exactly. It's the fastest model there, period. Average latency, just 25 milliseconds.
25 milliseconds, that's incredibly quick. Faster than GPT-4 Mini, you mentioned?
Yeah, they're about 4 times faster in their tests.
Uh-huh.
So for a developer, that difference is huge. It goes from a noticeable pause to feeling practically instantaneous.
Okay, so the speed is undeniable, and the quality seems to be there, too. You mentioned coding benchmarks.
Right. They tested across C++, Java, JavaScript, PHP, Bash, TypeScript, the usual suspects. And it maintains comparable quality scores.
Impressive.
And it even gets state-of-the-art results in fill-in-the-middle tasks, or FIM.
FI. That's where it completes code between existing code, right? Crucial for good auto-completion.
Precisely. It shows the model really understands the context, not just predicting the next thing.
So zooming out a bit, does using this diffusion approach mean you have to rewrite everything to use Mercury?
That's another key point, no. Underneath, they've kept the familiar transformer architecture.
Okay, so it plugs into existing systems more easily.
Yeah, potentially. It could act almost like a drop-in replacement for current autoregressive models. You get the speed and efficiency benefits without needing a massive overhaul of your infrastructure.
Which means lower costs.
Potentially significantly lower inference costs. Running these big models is expensive, mostly due to the computation needed at inference time, if Mercury is that much more efficient.
It could make powerful AI much more affordable and accessible for more applications.
Exactly. It's not just faster coding. It's about changing the economics of deploying AI.
So, wrapping this up, Mercury really looks like a significant leap. It's making powerful LLMs not just smart, but also incredibly fast and efficient, especially for these demanding coding tasks.
It really does seem like a potential step change,
Yeah.
which leads to a really interesting thought for everyone listening.
Go on.
Well, given that Mercury, or technologies like it, could dramatically boost AI speed and slash costs, how might that kind of ultra-fast, much more accessible AI change the way you personally work or learn or even just interact with technology day to day? Something to think about.
It's definitely food for thought. Thanks for breaking that down for us.
My pleasure.